All right, Team Tillman. So, up to this point, we've done a lot of software development and we've written a lot of code, right? But the question should be, how do we know if our code is correct, short of running the application or me actually grading it and telling you whether it's correct or not? But how do we know whether those objects that we created with constructors, whether the code that we wrote in the clock out or whatever method that we've written works? Well, this is where software testing comes into play. So this first lecture, we'll talk about why we need software testing. All right, so what exactly is a computer bug? So way back in 1947 over at Harvard University, they had a big room-sized computer called Mark II. All right, see that over there to the right? Awesomeness. All right, and they had a whole bunch of mechanical relays, vacuum tubes, blah 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 blah. So what happened was this moth flew into the computer, right, and broke it. All right, so that was actually the first computer bug, and it was the term was coined by Rear Admiral Grace Hopper. So that's a very familiar name in this field. If you don't know who she is. All right, so you'll hear bugs by other names, right? Defect, that's more so what we call it in the industry. Fault, a problem, error, incident, anomaly, variance, failure, inconsistency, product anomaly, product incidents, and sometimes even a feature is considered a bug, something we've added erroneously. All right, so when we write software, unfortunately, our software contains many types of defects. Whether we know them or not, right? So there's defects that are in our code that sometimes we won't even see until we actually start using the software in the field. So if you are under the assumption that you can write bug-free software right off the bat, it's nearly impossible. All right, so where do these bugs come from then? Are they all just on the programmer? Well, one of the biggest places of introduction of bugs or problems is the requirements definition. So remember, we go out to the users and we ask them or try to develop the requirements for our system, right? Sometimes those requirements aren't correct, sometimes they are relayed incorrectly, sometimes they are interpreted wrong. So there's a lot of room for errors just in the requirements definition. All right, and sometimes the architect, i.e. people like me, will design the software wrong, right? So for instance, we looked at if a lot of you paid attention, when I went back and reviewed your clock in and clock out, I actually said that you could use the current time as the clock in value and not pass it into the method. Well, that's actually a design flaw, because if you look at the timesheet where the data was coming in from, then the clock in and clock out times are there, so we would actually need to pass those values to the function, right? So that's what we call a design flaw, and I introduced that purposely. All right, implementation, right? Sometimes we write the code incorrectly, divide by 0 or something. All right, the support system, sometimes we just have terrible languages, right? i.e. PHP. I'm sorry for all you PHP lovers out there, but it's terrible. All right, another source of problems is inadequate testing of software. Sometimes we rush to get the software out and we don't test it properly. All right, and sometimes as the software evolves over time, we will add bugs in it or introduce new bugs. All right, so, well, what are the adverse effects of bad software, right? So if we're talking about communication systems, right, then we could have a loss or corruption of the communication media, non-delivery of data. So I don't know if you've ever been on a phone call and the phone call breaks up, or what if you were calling your wife and you were joking around and you said, "I hate you," but you really were going to turn right back around and say, "No, I'm just kidding, I love you." And all of a sudden you said, "I hate you," and your phone call dropped. Looks like the couch for you, buddy. All right, so space applications, right? Man, we could lose lives or delay the launches, and we've seen that before. In defense and warfare software, we can misidentify a friend or a foe and possibly have friendly fire deaths. In transportation, right? Cars could accelerate suddenly, etc. We just saw that with Volkswagen. Safety critical applications, death, injuries, electric applications, we can lose power. You can lose power to a hospital and everybody dies, terrible thing. All right, money management. You get a lot of fraud. The stock exchange could shut down. Uh, Elections, right? Somebody could vote for somebody that they didn't intend to vote for. Go ahead, George Bush. No, I'm just kidding. All right, control of jails, law enforcement. Yeah, you could get arrested by mistake. All right, so as an example, Project Mercury had some code written in Fortran, right? So if you see that, that's actually a loop in Fortran, do I equals, right? So the developer wrote do I equals 1.10, and what they intended to write was do I equals 1 comma 10, meaning go from 1 to 10. All right, so they found that flaw doing the analysis of the software, right? But really what would have happened if that code had went in production is that it would have only iterated one time. So it's very easy to introduce those bugs. Just the difference between a period and a comma makes a significant difference in code. All right, and F18 actually crashed one time because it was missing an else statement, right? In simulation, the bug caused the virtual plane to flip over when it crossed the equator, right? Because it was missing a minus sign to indicate south latitude, something that minor. All right. Back in 1982, Mary Bander received an invitation to start kindergarten. Right. She was already 104 years old at the time. All right. Mr. Blodgett, his auto insurance tripled when he turned 101, and these are actually real stories. All right. So the program he was using, he was actually the first driver over 100, and the developer didn't plan for that. So the program actually interpreted his age as 1 year old. So, of course, I guess it's very dangerous for a 1-year-old to be driving. His auto insurance tripled. All right. Sometimes we have date, time, and integer errors that cause problem, right? Buffer overflows, etc. So we actually saw a hospital computer system crash in Washington, D.C., making them use it manually. All right, COBOL has some errors. We'll skip that. We had a power plant shut down back in 1979 because of the math. All right. And more seriously, right, with radiation therapy, there was a man back in 1986 who received too much radiation, and he actually lost his arm and died 5 months later. So you have very consequences that could be very serious from some of the bugs that we introduce. All right. AT&T's had its share of bugs. Blocking calls back in 19 million, 5 million calls were blocked, 9 hours. Lots of unhappy customers. So the bug was actually traced to a C program, and C is notorious for buffer overflows and bugs in it, but it was actually a break statement in a switch cause nested within a loop. All right. All right. Bank gave away a lot more money than it should be. I wish my bank would give me some money. Interesting, man. An Australian guy purchased $104,500 worth of Sri Lankan rupees. Right, sold it the next day for $440,000, and it was all because the software at the first bank had a bad exchange rate. Why do those mistakes never happen to me? God. The Bank of Boney, right, in New York, $32 billion overdraft as a result of a 16-bit integer counter that went unchecked. Right, $32 billion overdraft. Somebody's losing their job. Alright, so software bugs occur when at least one of these rules is true, right? The software does not do something that the specification says it should do. So we have a requirements documentation that said it should calculate the interest at 0.8% and it's calculating it at 8%. That is a bug from the specification. Alright, the software does something that the specification says it should not do, right? So if the specification does not say that I should charge $50 for an overdraft, and my software does that, that is considered a bug. Unless the users sign off and say, hey, yeah, that's what we really wanted it to do. Right? The software does something that the specification does not mention. Again, same thing. The software does not do something that the product specification does not mention but should. All right, and the software is difficult to understand, hard to use, and slow. Yes, those are bugs. If your software cannot be maintained, if it's written poorly, if you have poor variable names, if you have a series of nested loops that are just hard to maintain, that is buggy code because it leads to buggy code. All right, so most of the bugs are actually not in the code themselves, right? 55% of the bugs are in the requirement specification themselves. All right, so you'll say, well, how do we fix that? So we'll talk about types of testing that help us with those areas. So the specific area there is what we call acceptance testing, or actually behavior-driven design, or BDD. All right, and we really won't go that much into that. Where we're going to focus in this class is that code phase, that 15%, what we as developers do, which is unit testing. All right, and it is actually better to find a bug up front than it is to find it later. The later you find that bug, the more expensive it is to fix, right? So that's why we want to find our bugs as early as possible. So one of the key approaches to that is what we call test-driven development. And unfortunately, we don't have the time to really get into TDD, but I urge you to find a good book on test-driven development and read that and become familiar with it, because you will use that a lot in the industry. All right, so bug-free software, right? Almost impossible, right? So the key is how do we find the bugs earlier, and we'll talk about the techniques for how we find our bugs earlier and minimize the scope of our bugs and the number of our bugs in our software. All right, catch you later.